And welcome to our Zero Coding Artificial Intelligence and Machine Learning course brought to you by Spotflock. With artificial intelligence, we want to augment the abilities of people to enable us to accomplish more, to eliminate tedious repetitive tasks, and allow us to spend more time on our creative endeavors. The growth of AI and machine learning is going to be more impactful than the invention of the personal computer and the spread of mobile phones in your pocket. So what is this course all about? Well, the field of artificial intelligence and machine learning is extremely broad, and to become an expert in this field can be very difficult since a strong background in computer science, as well as a proficiency in programming languages is required. We wanted to eliminate these barriers and democratize AI. And that is why we have partnered with machine learning experts and professors with a cumulative experience of 80 plus years to introduce the first zero coding artificial intelligence and machine learning course using our very own zero coding machine learning platform, Spotflock Studio. We will go over topics like classification, regression, clustering, natural language processing, and computer vision. And moreover, for every one of those branches of machine learning, we will look at different algorithms and how they can be applied to assist you with machine learning. Taking real-world examples like predicting house rates, probabilities of loan defaulters, and global supply chain outcomes will be covered to give a taste of real-world problems and analytics. So overall in this course, you'll be learning the theory behind all these algorithms, as well as going over a few case studies where we can apply these very algorithms without even an inch of coding. We are constantly adding new material and updating this course regularly. We look forward to beginning your journey as a Spotflock certified AI/ML professional. Welcome to Spotflock Studio. Studio hosts a wide range of products and services across AI, analytics, IoT, blockchain, computing, and other developer tools with our unique zero coding platform. Visit our page to create your own account to access these services. Once your account has been validated, you can access the Spotflock Studio website to log into the dashboard. Here is our studio catalog, where we have a wide variety of products and services across two categories, namely AI Suite and Analytics. We also provide each user with cloud storage that can be upgraded as well. At any point of time, one can view the storage to access or upload any datasets you would like. You can also upgrade your storage by selecting any of the add-on packs available. So let's take a look at a few of our products. First, our machine learning platform, where one can create custom models and perform analysis on data without learning how to even code. Once a plan is activated, you will have the ability to access the Phoenix ML dashboard. Once you access the dashboard, you will have three options. One, to create or view machine learning models, or train those models as well as test those models using real-world data. Let's create a new model. But before creating a new model, we need the data that we will use to train it as well as the data we would test it with. So let's go to our storage options and upload our data. For this example, we have collected data on house pricing so that we can predict future prices based on select features. We can select the training data to be uploaded and then the test data that needs to be uploaded as well. We now proceed to create our ML model. The Studio allows you to create a classification or regression based model. Since we are trying to make a prediction, we will make a regression model. Add a custom name to your model, say housing model, and select the regression algorithm from the drop-down menu next to it. We then need to select the data that we are going to train the model with. The Library tab shows a list of generalized datasets that have been provided for free to practice with. You can also view the datasets uploaded onto your cloud storage onto the other tab. After selecting your dataset, we choose the ratio in which we want to split the data as training and evaluation data. Say 80% training and 20% evaluation data. We then select a list of features or attributes that we want to consider as factors for our prediction model. Then we select the label or class that we are performing a prediction for, that is, in this case, the selling price. We then proceed to train our model, and after giving it a moment to work with, you will see your model in the same menu. We can now try to test the model and make a few predictions. Select the test data from the previously uploaded datasets from your cloud storage. We select our housing model and then select the attributes which were required to generate our model. Once the predictions are generated, they can be viewed within the dashboard itself or can be manually downloaded in the form of a CSV file. Phoenix ML also has a section to learn and study machine learning courses and can be certified as well. We offer an advanced AI course where you can learn all the concepts that were used in Spotlock Studio. You can track your progress and claim your certificates once courses have been completed. Within the course, you have access to the curriculum and course contents. You can then continue to access a range of videos and content for each section individually. We also have other services like Phoenix Vision, which is used to analyze visual content like facial recognition, which we currently support. Selecting the service, we have an option to upload our own photo or select one of the photos provided. Faces in the images will be detected. You also have the option to use this as an API and continuously pass multiple frames and detect faces. Similarly, Phoenix Language is a language processing service where you can extract metadata from text-based data. We support sentiment analysis and POS tagging. In our sentiment analyzer, text can be inputted. For example, he is extremely happy. And after processing, the API can track the polarity or emotion in the text. To learn more, please register on studio.spotflock.com.
If you go back 20 or 30 years, very crude systems existed, which were called expert systems. These were simple programs which could answer a complicated problem because they were programmed with the exact steps a human expert would use to answer it. For example, if a doctor wanted to diagnose a stomach pain, they would check the patient's age, gender, pulse, temperature, blood pressure, whether the pain is at the top or the bottom, left or right, whether there is vomiting or diarrhea, etc. From that, they would follow a path through the different answers to get a likely diagnosis. Similarly, a computer would be programmed with the exact questions and the exact path for every combination of answers. The result is a computer program which could diagnose with the same or better accuracy of a human expert, since the computer program would never miss anything or have an off day. The problem with this type of system is that it isn't very flexible. Sometimes the expert might not know how to proceed. Sometimes information is missing. Sometimes the expert relies on some type of intuition. They can explain some of what they do, but not all of it. Now that we have more computing power available, there are now techniques available which allow a computer to determine its own rules on how to answer a difficult problem. Essentially, what the AI does is look for correlations for the data coming in and tries to match it to an output. There are methods of doing these correlations statistically using an algorithm like support vector machine, or you could do it by choosing a random set of rules and then tweaking them based on hits and misses with genetic algorithms and neural nets. So what's the real difference between AI and automation? The terms artificial intelligence and automation are often used interchangeably. Automation is software that follows pre-programmed rules, while artificial intelligence is designed to simulate human thinking. Automation has a single purpose, to let machines perform repetitive monotonous tasks. This frees up times for fleshy humans to focus on more important tasks that require the personal touch. The end result is a more efficient, cost-effective business and a more productive workforce. While artificial intelligence serves to create technologies that ably mimic what a human can say, think, or do. At the very highest level, AI is about creating machines capable of solving problems like we do through reasoning, intuition, and creativity. Automated machines collate data, AI systems understand it. Consumers don't always recognize it as such, as corporate marketing experts prefer to avoid technical jargon and instead use consumer-friendly names like Siri and Alexa. But for people that's more technically inclined, the ubiquitous presence of AI is hard to miss. Much of our day-to-day technology is powered by artificial intelligence. Fingerprint recognition, retina iris recognition, hand or palm recognition, which are the most commonly used biometric systems, are built using AI. Several companies are using AI to develop blood tests for detecting various cancers. AI is also now being used for the analysis of secondary risk factors for diseases which were previously considered too subtle to use as an accurate means of diagnosis. Several applications that are used for navigation continuously train their AI engines to provide the shortest or the fastest route, predict the traffic as well as calculate trip costs. Developments in artificial intelligence are looking more and more promising. The future has a lot more to offer. Soon we will be able to deploy robots that can easily handle complex and difficult tasks like bomb defusals. Development of large-scale smart cities where everything is integrated at the touch of your fingers. Automated public transport from your doorstep to your destination. Robots that will help us with mundane day-to-day tasks like cleaning the house and cooking your food. Soon we will be able to link your brain directly to computers and other electronic devices, preferably via cybernetic implants that allow us your mind to interface with gadgets and programs. AI is everywhere, from autonomous driving software to Watson Analytics to Google Maps to your favorite e-commerce deal site, all based on AI topics and techniques that have been in development since the mid-50s. To say we don't have a general AI is simply because most of our specific forces. That is rapidly changing though, and we are seeing some great advances. To learn more, visit studio.spotflock.com. To put it simply, machine learning can be defined as an approach to achieve artificial intelligence through systems that can learn from experience to find patterns in a set of data. It essentially combines the principles of computer science and statistics to create statistical models which are generally used for discovery, that is inference of patterns from data, or predicting, using previously collected data to make future predictions. Just like humans, these products effectively learn from three sources: through observations, observing what others have done; through decisions, conclusions, by observing a situation and designing the best possible logic, or through learning from previous successes and failures. These computers can apply what they have learned from existing data to forecast future behaviors, outcomes, and trends to solve problems. For example, an algorithm can be trained with cars to recognize cars. The very same algorithm can be trained with dogs to recognize dogs without changing anything in the program. Artificial intelligence is the study of agents that perceive the world around them, form plans, and make decisions to achieve their goals. Its foundations include mathematics, logic, philosophy, probability, linguistics, neuroscience, and decision theory. Many fields fall under the umbrella of AI, such as computer vision, robotics, machine learning, and natural language processing. Machine learning is a subfield of artificial intelligence. Its goal is to enable computers to learn on their own. A machine learning algorithm enables it to identify patterns in observed data, build models that explain the world, and predict things without having explicit pre-programmed rules and models. There are three fundamental types of machine learning: supervised, unsupervised, and reinforcement learning. Supervised learning is characteristically done in the context of classification, when we want to map our input to output labels, or regression, where we want to map the input to a continuous output. Unsupervised learning, on the other hand, allows us to approach problems with little or no idea what our results should look like. We can derive structure from data where we don't necessarily know the effect of the variables. We can derive this structure by clustering the data based on relationships among the variables in the data. Reinforcement learning is a type of machine learning algorithm which allows software agents and machines to automatically determine the ideal behavior within a specific context to maximize its performance. Reinforcement algorithms are not given explicit goals. Instead, they are forced to learn these optimal goals by trial and error. Machine learning plays a very crucial role in today's time, knowing well how it has changed and improved how various processes of different industries run. In finance, statistical arbitrage refers to automated trading strategies that are typical for the short term and involve a large number of securities. In such strategies, the user tries to implement a trading algorithm for a set of securities based on quantities such as historical correlations and general economic variables. Given a digital photo album of many hundreds of digital photographs, programs can identify those photos that include a given person. A model of the decision process would allow a program to organize photos by person. Some cameras, softwares like iPhoto, and services like Facebook have this capability. In the age of big data, brands now have access to more information than ever about their customer base. One of the main challenges of social media marketing is segmentation, targeting people with content that they are interested in based on their online activity and demographics. Using a mix of big data analysis and machine learning, brands can effectively target users with messaging in a language that they can really understand and push offers, deals, and ads that appeal to them across a range of channels. To learn more, visit studio.spotflock.com. To get started with Spotflock Studio, open your browser of choice and go to our page studio.spotflock.com. If you are a new user, sign up and create a new account. Fill in the necessary details and register with our studio. A confirmation will be sent to your provided email and then you can proceed to log in. Once in, you can see your available storage as well as your Spotflock cloud units. Various SEU packages can be bought and coupon codes with free SEUs can be redeemed as well. Each student who registers for our course is provided with a coupon for 50 SEUs in the documents attached. These Spotflock cloud units will be used for performing tasks and functions within the studio. You can then continue to learn and apply machine learning from a wide catalog of services on our studio. For more information, visit studio.spotflock.com.
In supervised learning problems, we start with a dataset containing training examples with associated correct labels. For example, when learning to classify handwritten digits, a supervised learning algorithm takes thousands of pictures of handwritten digits along with labels containing the correct number each image represents. The algorithm will then learn the relationship between the images and their associated numbers and apply that learned relationship to classify completely new images that the machine hasn't seen before. Machine learning models are not too different from a human child. When a child observes a new object, say example for a dog, and receives constant feedback from its environment, the child is able to learn this new piece of knowledge. Supervised learning is done using a ground truth, or in other words, we have pre-existing knowledge of what the output values of our sample should be. This dataset contains training examples with correctly associated labels. The goal here is to develop a function given that, given sample with previously decided metrics to be recorded, best approximates the relationship between input and output observable in the data. The form and content of the training data, often referred to as labeled or human labeled data or ground truth dataset, is designed for training specific ML models with an end application in perspective. We pass this data through an algorithm, which is defined in terms of machine learning models, so that the program can generate correlations and understand the data well. Each machine learning model needs to be tested in the real world to measure how robust its predictions are. This is data that is never seen before. Just as a student comes across fresh problems with an exam, models too need to be similarly challenged so as to evaluate their performance and accuracy. These models can be trained again and again as many times as you'd like, so that you can improve on the accuracy of your generated predictions. Supervised learning is characteristically done in the context of classification when we want to map our input to the output labels, or regression, where you want to map the input to a continuous output. The goal of both regression and classification is to find specific correlations or structure within the input data that can allow us to efficiently produce output data. It shall be noted that since the precision of our output is dependent on the data used to train it, noisy or incorrect data labels will visibly reduce the effectiveness of your model. Classification is the process of predicting the class of given data points. Classes are sometimes called targets or categories. Classification predictive modeling is the task of approximating a mapping function from input variables to discrete output variables. Classification belongs to the category of supervised learning, where the targets also provided with the input data. There are many applications in classification in many domains, such as in credit approval, medical diagnosis, target marketing, etc. The most common algorithms devised for these purposes are naive Bayes, support vector machine, artificial neural networks, logistic regression, and random forests. Decision tree classifier is a simple and widely used classification technique. It applies a straightforward idea to solve the classification problem. Decision tree classifier poses a series of carefully crafted questions about the attributes of the test record. Each time it receives an answer, a follow-up question is asked until a conclusion about the class label of the record is reached.
Building an optimal decision tree is a key problem in decision tree classifiers. In general, many decision trees can be reconstructed from a given set of attributes. While some of the trees are more accurate than others, finding the optimal tree is computationally infeasible because of the exponential size of the search space. However, various efficient algorithms have been developed to construct a reasonably accurate, although suboptimal decision tree in a reasonable amount of time. These algorithms usually employ a greedy strategy that grows a decision tree by making a series of locally optimum decisions about which attribute to use for partitioning the data. Let's take a look at how we can train a classification model to assess player activity for an online mobile game through the Spotlock Studio. From our dashboard, we upload our training data through which we would like to train our model, as well as the test data used for testing our model. These files have been uploaded in the CSV format. We now proceed to train our classification model. Let's assign a name to the model. We select our classifier from the drop-down menu. For this example, we have selected the random tree classifier. We select our training data from the data that we have uploaded. Our data is split into 90% training and 10% test data. We select our class attribute as player activity and a few features we would like to consider to generate our prediction. Once the model has been trained, we can assess the accuracy of our classification model along with other metrics like the error rate and entropy. Now we can use our test data to predict trends from our trained model. Selecting the attributes we use to train our model, we can generate new predictions. The predicted results are displayed below. More data can be uploaded to train the model to improve the accuracy of these predictions. To learn more, visit studio.spotflock.com. In statistical modeling, regression analysis is a statistical process for estimating the relationships among variables. It includes many techniques for modeling and analyzing several variables when the focus is on the relationship between the dependent variable and one or more independent variables or predictors. More specifically, regression helps one understand the typical value of the dependent variable or criterion variable changes when any one of the independent variables is varied while the independent variables are held fixed. In classification, we train a predictive model to produce a class or category. Regression is used when you need a predictive model that produces numeric values instead of classes. For example, you would use a classification algorithm to predict the probability of rain, but use regression analysis to predict the temperature. Most commonly, regression analysis estimates the conditional expectation of the dependent variable given the independent variables, that is the average value of the dependent variable when the independent variables are fixed. The goal of both regression and classification is to find specific correlations or structure within the input data that can allow us to efficiently produce output data. It shall be noted that since the precision of our output is dependent on the data used to train it, noisy or incorrect data labels will visibly reduce the effectiveness of your model. Many regression algorithms have been utilized to learn of these correlations. Linear regression, support vector regression, ordinal regression, and logistic regression are some of the most popular regression algorithms out there. Linear regression attempts to model the relationship between two variables by fitting a linear equation through observed data. The first variable is considered as the explanatory variable, while the second variable is known as the dependent variable. The dependent or response variable refers to values we want to explain or forecast, while the independent variable is one that explains these very values. And these variables and the values are independent of each other. Linear regression can be used one of two ways: to see if there is an established relationship between the two variables, or see if there is a statistically significant relationship between them. Simple linear regression is a type of regression analysis where there is only one independent variable, and the independent and dependent variables have a linear relationship. The line that passes through the maximum number of points is named the best fit line. Based on varied data points, the objective is finding the best fit line. This is hence modeled using a linear equation y is equal to mx plus c. The aim of the algorithm is to locate the best values for m and c that provides the best fit line. Let's take a look at how we can train a regression model to predict housing prices through SpotFlock Studio. From our dashboard, we upload our training data through which we would like to train our model, as well as the test data used for testing our model. This data is presented in the way of a CSV format. Once both the training and test data have been uploaded, we now proceed to train our regression model. From the dashboard, we select Training Models. We generate a new model for regression. Let's assign a name for our model. We select our model from the drop-down menu. For this example, we have selected linear regression. Then we select the training data that we had uploaded. Our data is split into 80% training and 20% test data. We select our class attribute as sale price and few features we would want to consider to generate our prediction. Once the model has been trained, we can assess the accuracy of a regression model along with other metrics like error rate and entropy. Now we can use the test data to predict trends from our trained model. Selecting the same attributes we used to train our model, we can generate new predictions. The predicted results are displayed below. More data can be uploaded to train the model to improve the accuracy of these predictions. To learn more, visit studio.spotflock.com. What is the fundamental difference between programming and machine learning? When people talk about machine learning, they're talking about a particular design for a program, but it's still programming.
For example, let's say you have two tennis balls. One is the normal greenish color, the other one you've painted blue. Now you have a robot that needs to pick up only the blue tennis balls. One way you could program it is to tell it directly to just ignore green ones and pick up the blue ones. But maybe you don't know which ball the robot needs to pick up. Let's just say that it's a competition and you won't know the colors of the balls until after you program the robot. But you needed to bring only the blue ones. So how do you program it? Well, you can program it to bring you the balls at random first, and then you will give it some signal when it brings the correct color. And after that, it will only bring more of that color. That is a type of supervised learning. The key thing to notice though is that you are still programming the robot to behave in a very determined manner. So you have to know exactly how it learns, otherwise you can't program it. In this example, you were telling it when it found the right ball or not. So you were supervising the learning process. Unsupervised learning comes in when you either can't or don't want to be monitoring the whole process. How do you find the underlying structure of a data set? How do you summarize it and group it more usefully? How do you effectively represent data in a compressed format? These are the goals of unsupervised learning, which is also called unsupervised because you start with unlabeled data. In contrast to supervised learning, it's not always easy to come up with metrics for how well an unsupervised learning algorithm is doing. Performance is often subjective and domain specific. Let's take another example. Say we want to figure out if people with more Twitter followers typically make higher salaries. We think that our input might lead to our output, and we try to approximate what that relationship is. The stars are data points, and machine learning works on creating a line that explains how the input and outcomes are related. But in unsupervised learning, there are no outcomes. We're just looking to analyze in the input, which is our Twitter followers. There is no salary or why involved at all, just like there being no answer key for the test. Maybe we don't have access to salary data, or we're just not interested in the same questions. It doesn't matter. Let's just look at the primary method through which we perform unsupervised learning, clustering. Clustering is the process of grouping similar entities together. The goal of this unsupervised machine learning technique is to find similarities in the data point and group similar data points together. Clustering can be considered the most important unsupervised learning problem. So as every other problem of this kind, it deals with finding a structure in a collection of unlabeled data. A loose definition of clustering could be the process of organizing objects into groups whose members are similar in some way. Grouping similar entities together help profile the attributes of different groups. In other words, this will give us insight into the underlying patterns of different groups. K-means clustering is a type of unsupervised learning which is used when you have unlabeled data. The goal of this algorithm is to find groups in the data, with the number of groups represented by the variable k. Each cluster has a cluster center called the centroid. The algorithm works iteratively to assign each data point to one of the k groups based on the features that are provided. Data points are clustered based on feature similarity. Given k, the k-means algorithm works as follows. First, we choose k random data points to the initial centroids or cluster centers. Then, we assign each data point to the closest centroid. Here the hyperparameter used is Euclidean distance. We then recompute the centroid as an average of all the data points in that cluster and continue to do so till no further changes occur. Hierarchical clustering, as the name suggests, is an algorithm that builds hierarchy of clusters. Unlike k-means clustering, this algorithm starts with all the data points assigned to a cluster of their own. The two nearest clusters are merged into the same cluster. In the end, this algorithm terminates when there is only a single cluster left. This algorithm has been implemented above using the bottom-up approach. It is also possible to follow a top-down approach starting with all the data points assigned in the same cluster and recursively performing splits till each data point is assigned a separate cluster. The decision of merging two clusters is taken on the basis of the closeness of these clusters. Unsupervised learning is an important type of machine learning as it allows the AI to self-improve based on large diverse data sets such as real-world experiences. An unsupervised learner processes 10 million videos together with related textual data such as descriptions and comments. The learner models images in the videos using statistical analysis that allows it to identify visual patterns. These patterns can be correlated with the text to develop theories about the visual traits of various things. A learner that possesses visually highly developed visual and speech recognition capabilities could watch a large number of television shows to learn about human behavior. For example, a learner might be able to build a model that detects when people are smiling based on correlation of facial patterns and words such as "What are you smiling about?" A highly developed AI that serves as a housekeeping robot develops a theory that there is usually dust under a sofa. Each week, the theory is confirmed as the robot finds dust under sofas. Nobody explicitly tells the robot the theory is correct, but it is able to develop confidence in it nonetheless. To learn more, visit studio.spotflock.com.
Computer vision concerns itself with building technology for obtaining information from images and multidimensional data. It is a study of replicating the human vision processes, passing them onto machines, and automating them. Computer vision is a field that includes methods for acquiring, processing, analyzing, and understanding images. The ultimate goal is to give computers the ability to extract high-level understanding from digital images and videos. When you look outside, you immediately recognize the objects in the yard. Without thinking, you're able to classify a dog as a dog, a tree as a tree, and a person as a person. That's your brain drawing knowledge from its extensive database. Remember, we have millions of years worth of evolutionary context and machines do not. Computers see images as just huge piles of integer values that represent intensities across color spectrums without any context. And that's where machine learning steps in. It allows us to train a context for a data set in a way that enables the machine to understand what objects certain sequences of numbers actually represent. CV is taking an increasingly harder task and in some cases provides stunning accuracy. Images on computers are most often stored as a big grid of pixels. Pixels are defined with colors basically red, blue, and green. Combining different intensities of these colors, what's known as an RGB value, we can represent any color. With these values saved, we can give a computer program an image and ask it to find the pixel with the closest color matches and detect features in an image. Today, the most widely used algorithms are convolutional neural networks. Convolutional neural networks is a special architecture of artificial neural networks and are popularly used in image classification. Instead of an image, the computer sees an array of pixels. For example, if the image size is 300 by 300, the size of the array will be 300 by 300 by 3. Where 300 is the width, the next 300 is the height, and 3 is the RGB values. The computer is assigned a value from 0 to 255 to each of these numbers. This value describes the intensity of the pixel at each point. The image is then passed through a series of convolutional nonlinear pooling layers and fully connected layers, and then generates the output. The very first convolutional layer might find things like edges, as that's what a single convolution can recognize. The next layer might have neurons that convolve on those edges, features to recognize simple shapes, comprised of edges like corners. A layer beyond that might convolve on these corner features and contain neurons that can recognize simple objects like mouths and eyebrows. And this keeps going, building up in complexity until there is a layer that does convolution that puts it together. Eyes, ears, mouth, nose, and labels the entire project as a face. Computer vision is about extracting meaningful information from images. Face recognition, in particular, is about mapping a face to a known identity in the database. The systems are becoming so advanced that they can measure, quantify, and cross-reference data points like skin tone, facial expressions, eye width, and more. This information can be collected and used to determine behavioral patterns, internal modes, and even future ones. Medical imaging has been on the rise for years, and multiple healthcare startups have been partnering with prominent hardware providers to build bleeding-edge computer vision tools. One of the most popular use cases up until recently was leveraging convolutional neural networks to detect diseases from an MRI. Apart from self-driving cars, there's a broad array of use cases for computer vision in the automotive industry. Some companies, for example, use the tech to have cars automatically set speed limits, detect lanes, interpret signs, and perform an overall scene analysis. Through the Spotlock Studio, we can study one of the most common applications of computer vision, face detection. From the catalog of services, we can select Phoenix Vision, which is a dedicated service for computer vision applications. From the dashboard, we then proceed to our face detection microservice. We now have the ability to upload an image of our choice to test from our computer itself. The image is then passed through our algorithm and then the detected regions are displayed. To learn more, visit studio.spotlock.com.
So what is natural language to begin with? Basically, it's the language we humans use to communicate with each other, whether it's English, Spanish, or Mandarin. NLP is a specialization of machine learning that makes computers capable of understanding human language, analyzing it, and performing actions accordingly. NLP is now widely used in fields like speech processing, sentiment analysis, information retrieval and extraction, machine translation, and many others. NLP algorithms cannot read text like we do, but they can look for patterns. And they find these patterns by turning huge amounts of text into matrices. When analyzing text, the algorithm might first remove words that don't really offer as much value. Words like the, is, and are called stop words. Then the algorithm might split the sentences into a group of words and count how many times each group of words appears in each document, and how many documents that group of words out of all the documents being analyzed. Without knowing anything about the text, the algorithm can tell how often a given word or phrase appears in a given document, and how many documents contain that phrase out of all the documents. So, tokens that appear a lot of times in lots of documents may not mean much, but tokens that appear frequently in only a few documents tell us that something's going on. In NLP, words and the surrounding context are pretty important. A word surrounded by relevant context is valuable, while a word surrounded by seemingly irrelevant context is not very valuable. Each word is mapped to a vector defined by its features, which in turn relate to the word's surrounding context, and neural networks can be used to learn which features maximize the word vector score. An artificial neural network is a computational nonlinear model based on the neural structure of the brain that is able to learn to perform tasks like classification, prediction, decision making, visualization, and others by just considering examples. An artificial neural network consists of artificial neurons, or processing elements, and is organized in three interconnected layers: input, hidden, that may include more than one layer, and output. The input layer contains input neurons that sends information to the hidden layer. The hidden layer sends data to the output layer. Every neuron has weighted inputs, an activation function, and one output. Synapses are the adjustable parameters that convert a neural network to a parameterized system. Current researchers are investigating the use of recursive neural networks to learn how sentences are broken down into tree structures. This recursive deep learning network can then successfully learn how to map similar sentences into the same vector space, even though they may be composed of words that mean entirely different things. With convolutional neural networks being widely used in computer vision, they also started to get applied to language. A convolutional neural network for text only operates in two dimensions, with the filters only needing to be moved along the temporal dimension. A simplified view of natural language processing emphasizes four distinct stages. Through the means of speech or text, a statement is collected. We perform a syntactic analysis using grammatical knowledge that defines the types of words in the statement. Then, the meaning behind those words are extracted through a semantic analysis. Finally, with the existing content in a pragmatic analysis will help us represent the meaning of the sentence. Modern approaches are based on machine learning, where gigabytes of real human-to-human chats are used to train chatbots. Today, the technology is finding use in customer service applications where there are already heaps of information to learn from. Using NLP statistics or machine learning methods, we can extract, identify, or otherwise characterize the sentiment content of a text unit as something positive, neutral, or negative. Almost everyone that uses email extensively has experienced agony over unwanted emails that are still received, or important emails that have accidentally caught in the filter. The false positive and false negative issues of spam filters are at the heart of NLP technology, again boiling down to the challenge of extracting meaning from strings of text. Virtual assistants or tools are intended to replace some of the day-to-day functions and responsibilities of people. They decrease the time you might spend on mundane tasks in order to allow you to free up your time to do more interesting, strategic, and hopefully impactful things. To learn more, visit studio.spotflock.com.
Indian house prices will rise at half the rate of consumer price inflation next year, hit by dwindling credit supply according to Reuters poll of housing market experts, who said Delhi, the national capital, will be hit hardest. House prices have risen at almost double-digit rates for over a decade in a country of 1.3 billion people, where for many, owning a home is still a dream. Major cities in India have become some of the most densely populated in the world. Rising bad debts and non-performing assets have made major banks and other large financial institutions cautious on lending, leading to a slowdown in the property market, which relies heavily on borrowing for both home building and buying. Home buyers are most concerned about the ups and downs of housing prices. However, during the long process of comparison of any real estate, many buyers might miss the opportunities to purchase due to the rise in house prices. In order to solve this problem, accurate prediction information for future fluctuations of the housing price is required to be provided to the buyers. Nowadays, at home and even abroad, the prediction of house pricing is in the research stage, and there is no practical business application. The earliest analysis of housing price mainly analyzed the trend of housing price at the macroeconomic level. In recent years, with the development of big data, machine learning methods have become one of the most important prediction methods because it can predict the price of each house more accurately by analyzing the feature attributes of the house. Housing prices are an important reflection of the economy, and housing price ranges are of greater interest for both buyers and sellers. In this project, house prices will be predicted given explanatory variables that cover many aspects of residential houses. As continuous house prices, they will be predicted with various regression techniques. In this case, a person wants to buy a home or a location of his interest with good features at a reasonable price. They would want to know if the value of the house along with various features match the house price. With the given data set we have, we can understand the features which influence them for the final price. For everything to go well, they need to ensure that they're getting a fair price in accordance with other buying factors. When the buyer goes to a contractor or the owner of the house who is showing the property, many attempts at influencing the buyer will be made. The buyer would like to buy in the lowest price he could afford with good features, while the owner will be trying to maximize his returns on the investment. The value of a house is more than what we think, and to predict the prices of the houses with the related details involves a couple of steps: loading data, analyzation of test variable, multiple variable analysis, impute missing data and clean data, modeling and predictions. The benefit to this study is that we can have two clients at the same time. Client house buyers, that the client wants to find the next dream home with a reasonable price tag. They have their locations of interest ready. Now they want to know if the house price matches the house value. With this study, they can understand which feature influences the final price of the house. If all matches, they can ensure that they're getting a fair price. And then there are house sellers. Think of the average house flipper. The client wants to take advantage of features that influences the house price the most. They typically want to buy a house at a low price and invest in the features that will give the highest return. For example, buying a house at a good location but small square footage, the client will invest in making rooms at a small cost to get a large return. We load the CSV file of the data and divide it into two sections called the train and test data. We take 80% of the data for training and the remaining for test. After that, we verify and save the samples and the features of the data. We save the ID columns of train and test and drop it since it is unnecessary for the prediction process. and check the data size. Due to this, we notice some changes occur in the dataset. The dataset we have here shows the drop in sales price prediction as well as in the features of train and test. Here the influencing feature is sales price, which is showing some change. Now we get the description of the train set with an average house price section. To understand the change, we plot a histogram and get it fitted with the parameters used in the function and obtain a clean graph of the sales price distribution and probability plot distribution. It might look like a normal graph to understand, but when we look at the kurtosis score, there is a nice peak, but we have to prepare this data to be simple to understand. Now let us look at the variables, categorical and numerical. Categorical data is in categories. It is necessarily linear, but it follows some kind of pattern. Numerical data is data in the number form, which is plain, clean and simple to understand. We take the train set and check for the categorical and numerical data. This step provides us with clarity of the highest number of features possible, which can be related to the house price. For this step, we prepare the correlation matrix, which delivers the top 9 features which are mostly related to the sales price. Here is a short description of each. The overall quality, which rates the overall material and finishing of the house. Ground level area determines the living area per square foot. Garage for cars, size of garage car and capacity size. Garage area, the size of the garage in square feet. Total basement square footage. Total square footage of the basement area. First floor square foot. Full bathrooms above grade. Total rooms which do not include bathrooms. And year of original construction. Imputing missing data and clean data. How important is the missing data? Does it have a pattern and its effect on the cost? The missing data is very important because it implies a reduction of the sample size and overall cost of the house or property. If the missing data has a significant effect on the cost of the house, we cannot proceed with the analysis. We need to ensure that the missing data process is not biased in hiding truth. Let's combine the both training and test data into one data set to impute missing values and do some cleaning. We combine the datasets and check the missing data by feature. After we get the missing data, we recheck it for any missing values. For regression models, we try to solve the following problem. Given a process list of features for a house, we would like to predict its potential sale price. Linear regression is a natural choice of baseline model for regression problems. So we first ran linear regression including all features using our 288 features and 1000 training samples. The model is then used to predict sales price of houses given features in our test data and is compared to the actual sales price of the houses given in the test data. The performance was measured by root mean square error of the predicted reviews and results. Visit Spotflock Studio and try your own hand on this dataset. Loans are one of the most important products of banking. All the banks are trying to figure out effective business strategies to persuade customers to apply their loans. However, there are some customers behaving negatively after the application has been approved. To prevent this situation, banks have to find some good methods to predict customers' behavior, and machine learning algorithms have had a pretty good performance on this purpose, which are widely used for banking. Here, we will work with our loan behavior prediction using machine learning models. Distribution of loans is the core business part of almost every bank. The main portion of the bank's assets directly come from the profit earned from the loans distributed by the banks. The prime objective in banking environment is to invest the assets in safe hands where it is. Today, many banks and financial companies approve loans after a rigorous process of verification and validation. But still, there is no surety whether the chosen applicant is deserving right applicant out of all the other applicants. The aim of this project is to provide quick, immediate, and easy ways to choose the deserving applicants. It can provide special advantages to the bank. The loan prediction system can automatically calculate the weight of each feature taking part in loan processing, and on a new test data, same features are processed with respect to their associated weight. A time limit can be set for the applicant to check whether his or her loan can be sanctioned or not. Loan prediction systems allow jumping to specific applications so that it can check on priority basis. Result against particular loan ID can be sent to various departments of bank so that they can take appropriate actions on application. This helps all other departments to carry out other formalities. It is very important that you or the data scientist working on this project finally measure and report the performance of the models on the data that has not been used at all during the analysis, all out of sample or test data. The idea is in practice that we want our models to be used for predicting the class of observations we have not seen yet. Although the performance of a classification method may be high in the data used to estimate the model parameters, it may be insignificantly poorer on data not used for parameter estimation, such as the out of sample or future data. This is why we split the data into an estimation sample and two validation samples, using some kind of randomized splitting technique. The second validation data mimics out of sample data, and the performance on this validation set is a better approximation of the performance one should expect in practice from the selected classification method. First, make sure the dependent variable is set up as a categorical 0-1 variable. In our illustrative example, we use the payment default or no default as a dependent variable. The data, however, may not always be readily available with the categorical dependent variable. Carefully deciding what the dependent 0-1 variable is can be the most critical choice of classification analysis. This decision typically depends on contextual knowledge and needs to be revisited multiple times throughout a data analytics project. Some of the widely used classification methods are classification and regression trees, boosted trees, support vector machines, neural networks, nearest neighbors, logistic regression, lasso, random forest, deep learning methods, etc. In logistic regression, it is a method similar to linear regression except that the dependent variable is discrete. Linear logistic regression estimates the coefficients of a linear model using the selected independent variables while optimizing classification criteria. Given a set of independent variables, the output of the estimated logistic regression, or the sum of the products of the independent variables with the corresponding regression coefficients, can be used to assess the plausibility of an observation belongs to one of the classes. Specifically,